On this slide, we talk about two important functions, the signum function and the greatest integer function. So signum function, fx is equal to 1 if x is greater than 0. It is 0 if x is equal to 0. And it is minus 1 if x is less than 0. So let us draw this. We draw the y-axis and the x-axis. So I have drawn 1 for x greater than 0, minus 1 for x less than 0. And for x equals to 0, we have 0 here. So there is a hole right here. So I've drawn a hole. There is a hole right here. Yeah. So I will just fill this hole with white color so that you know it is a hole at the y-axis. So there's a hole in the function here. There's no value here and there is no value here. Because at x equals to 0, it is 0. At the point minus 1, it jumps to 0 and then it jumps to 1. But it is a function, it takes exactly one value at every point. Fx equals to greatest integer function. So we will talk about the greatest integer which is less than or equal to x. So this will be clear by a number of examples. For example, say you have 1.5. So what is greatest integer less than equal to 1.5? So first we put 1.5 in an interval between two integers. So 1.5 lies between integers 1 and 2. And we pick the integer which is less than equal to 1.5. That is the lower end of the interval. So it is 1. Similarly with 2.7, we will pick up the interval in which 2.7 lies. So 2.7 lies between integers 2 and 3. Pick the lower end point which is 2. So number 2 again lies between integers 2 and 3. So you write it like this and then you pick 2. Yeah, so see, for 2 you have to take care it lies between 2 and 3. You don't lie it between 1 and 2. So for minus 1.5, it lies between minus 2 and minus 1. Again you pick the lower point. Minus say 0.5, it lies between minus 1 and 0. Again you pick the lower point. Minus 2, it is just minus 2. Yeah, for integer you don't change anything. So you say it lies between minus 2 and minus 1. You pick the lower end point. So basically for the integer you don't do anything, you just keep it like that. It is only for fractional parts when it matters. And for fractional parts you always write the fractional part lies between two integer points and you pick the lower integer point as the greatest integer function. So notice all of these are functions. And let us draw them now. So from 0 to 1 it is 0 because it takes the value of 0. So it always takes the value of 0 between 0 to 1 because 0 is the lower bound of this interval At point 1 it jumps, so between interval 1 and 2, if the value is say 1.5 or anything like that, it will always take a value of 1 because 1 is the lower bound. Similarly, between 2 and 3, it will take value of 2. So for 2.5 or 2.7, it takes value of 2, and so on. Yeah, again, it's a function. You can see this by a vertical line test, or you can simply see for every value on x-axis, it gets mapped to one value of y. So although 2.5 and 2.7 both get mapped to 2, but it is getting mapped to a single value in the y. Yeah, the value is not unique. 2.5 and 2.7 both get mapped to 2, but they get mapped to a single point, that is 2. Similarly, we have for negative numbers. So you have minus 0.5, it gets mapped to minus 1, and minus 1.5 or minus 1.7 gets mapped to minus 2. This is minus 1, this we write as minus 2. Say minus 0.5, and say here you have minus 1.5. Yeah, minus 1.5 gets mapped to minus 2.